Hello everyone. A few weeks ago, I came across a Creator Lab challenge on Wikibytes about fine tuning a small language model on personal writing. I realized that I understood prompting reasonably well, but I had never actually trained a model myself. So I decided to build the full workflow. For this project, I collected examples of my own writing, fine tuned Llama 3.2 using LoRA inside Google Colab, exported the result into GGUF format, and made it ready for local inference. And in this video, I will walk you through every step that I actually followed, including what changed during training and what all those files means. So before opening the notebook, let's define the goal. Large language models already know the language. So like we are not teaching them grammar or vocabulary. So fine tuning means taking an existing model and adapting it toward examples that we care about. In this case, it's my writing. And the goal here is not to memorize, the goal is to start picking up patterns like formatting, structure, tone, and explanation style. This became the complete workflow of the project, and everything from data creation to local inference happened inside this pipeline. We will go block by block. The first thing I needed was training data. So I collected examples from content that I had already written, mostly LinkedIn posts or Instagram captions or technical writing snippets from my article. Then I converted them into instruction response format. Instruction means what the user asks, and response means that what good output looks like. So each row becomes one training example. For this experiment, I have intentionally used a small curated dataset because quality matters more than simply increasing rows. Before starting, I switched my Colab to GPU mode. So training means that there are lots of matrix calculations, but GPU accelerates that process massively. Then I loaded my base model. Here I have used Llama 3.2 with Unsloth. So Unsloth is a library that makes fine tuning faster and more memory efficient. So even after loading, at this point, nothing has learned yet. This is still the original pre-trained model. Now comes the LoRA. So this was the part that made everything click for me. Like normally fine tuning means changing billions of parameters, but LoRA works differently. So instead of updating the entire model, it is attaching lightweight trainable layers called adapters. What happens is the base model stays mostly frozen and only these adapters learn. This is the exact place where LoRa got attached, and that makes training smaller, cheaper, and practical on Colab. So once the model was loaded, I just imported my dataset. Then I transformed the raw JSON into chat format, and this formatting step converts instruction response pairs into the structure Llama expects. Now the model and dataset both are connected. In the next step, I configured training. SFTTrainer stands for Supervised Fine Tuning Trainer. This tells training which model, which dataset, how many optimization steps, and how aggressively we should update. This is basically defining the learning process. This is where the fine tuning actually happened. So during training, the model predicts outputs, compares predictions against the dataset, calculates error, and updates LoRa adapters. This table shows training progress. Step means current update iteration. Loss measures prediction error. Logo generally means that the model is matching training examples better way, and epoch tells how much of the dataset has been processed. After the training got completed, this new file appeared. This file is important. So this is not the entire model, but this only stores the learned changes that were introduced by LoRa, like while training what else changed and what remained same. So this is the file that contains all of it. Now after completing all this, I tested prompts that never appeared in my dataset. Because the goal was not copying. I wanted to see whether the structure and writing patterns started appearing naturally. And this was the point where the workflow started feeling actual. After the training got completed, I exported the model into GGUF. GGUF is just a format that is optimized for local inference. So it packages the model into something easier to run outside training environments. So with the help of this, you can run your model locally in your machine. Once it is converted, the model becomes portable and now it can run locally using Ollama without opening Colab again. So this was a short walkthrough of this project, and this project actually gave me a much clearer understanding of what fine tuning actually is. And I finally understood where learning happens, what files get created, what LoRa stores, and how the model moves from training to deployment. Also, I have documented the complete process in an article. If you want to explore the implementation in more detail, I will put the link in the description. And this project started from a Creator Lab challenge on Wikibytes, which turned out to be a really good excuse to finally build and understand the full workflow end to end. So, if you want to explore Creator Labs, I am putting the link in the description again. Thank you so much for watching. Keep building, keep growing.